this terminal voltage is higher for the leading power factor, whereas in this case this particular voltage this voltage is higher, whereas the terminal voltage VA it is lesser for the lagging power factor. So, terminal voltage is higher for leading and smaller for the lagging power factor. That is what we can conclude from this. Then synchronous generators generally they are connected to a system. If it operates in isolation, so how does it behave? So, we are assuming that this generator is rotating at a constant speed and it is working in isolation, as can be seen from this figure, a generator connected to a particular load. Then as the load increases, so it increases the real and reactive power drawn from the generator. So, as we increase this particular load, the power that is being drawn from the generator it will increase, and since the windings are placed on the stator only, so that will affect stator and rotor will be unaffected of this. So, the field resistance is unaffected, field current is constant, so flux is not going to change. Similarly, the speed is also not going to change because it is not affecting that rotor part. So, we say that internal voltage that is generated is a constant, and if you assume the power factor to be constant, let it is feeding a particular load which is having a constant power factor. So, but the change in the load, let us suppose we are using 2 fans, then we are using 4 fans. So, the change in load will change the magnitude of the armature current, because if we use 2 fans, so obviously they draw particular amount of current. If you use 4, so they are again using slightly more amount of current. So, current will again affect that armature reaction voltage that is given by this JS axis IA. So, amount of IA is going to increase with the change in the load, and the voltage that is given by this is obviously the terminal voltage that we are getting plus the drop that is taking place because of this increase in the current in the reactance. That we have already discussed that equivalent circuit for this. So, there we can see that the voltage, terminal voltage can be easily calculated. So, here we can see this effect when it is operating in isolation for different power factor. We see that if the current is lagging in nature, so there we have a voltage, current is lagging in nature. So, we increase this current IA to IA dash. So, as a result of that, we can see that this voltage it is changed to this value. Similarly, for leading power factor, current IA is increased since power factor is kept constant. So, this IA is and IA dash is in the same line. So, the drop will also again change proportionally because the amount of this IA has changed. So, IA axis will also change with IA dash axis, and this is for unity power factor. Here IA is in phase with the voltage. So, we can see that this is the amount of voltage that we are getting. So, we can conclude from here, if you see this figure, that for lagging load phase voltage decrease significantly, phase voltage it is going to decreases here. For unity power factor it decreases slightly, the voltage it decreases, but it is small, and for leading this change is slightly large. But these these voltages they also affect the voltage regulation. Voltage regulation is basically the voltage that we are getting across a terminal. So, that should not change, because ultimately the voltage that we are getting across terminals is very important. So, how much change it that it takes place with change in the load, that is what we say is the voltage regulation. So, generally voltage regulation we gave it as voltage at no load minus voltage at load divided by voltage at no load multiplied by 100% voltage regulation. So, it is a change in this terminal voltage, because once we connect a load to any machine, so if we are changing this load, so there is some drop taking place in this in between. So, the voltage, this is your source voltage, or we say that ES, and this is your V terminal voltage. So, difference of this ES minus VT with respect to the no load terminal voltage is your percentage voltage regulation. So, if we increase this, it will increase the drop, and this drop is ultimately resulting in the drop in the net amount of voltage here. So, if we have to define it, so we can define it, it is load change or the voltage change across the terminal when load is changed from no load to the full load value at a given power factor. And we see the synchronous generator operating at lagging power factor. It has fairly large positive voltage regulation. So, smaller the voltage regulation, better is the voltage regulation. So, for different power factor they operate differently, and if you see for unity power factor it has small but positive voltage regulation, and for leading power factor it is negative voltage regulation. So, that means that the terminal voltage it is higher in case of the leading power factor as compared to the supply voltage. That is why, because the negative voltage regulation that we will get only if this is higher in as compared to the no load voltage. So, this voltage will be higher only if the drop is added, this drop is added to this. So, it is possible only if there is leading power factor. Now, another important aspect of synchronous generator is to operate them in parallel, because synchronous machines they are used for generation of the electricity. We talk of any generating station, whether it is thermal or hydro, there we are using synchronous generators, or they are also called as your alternators, and they all are operated in parallel to each other. And we know within India we have five regional grids, and nowadays we are they all are connected except southern grid. So, they need to be operated in parallel to each other, so that in case there is any disruption of any power supply, there has to be some maintenance, etc. So, they some supply can be that can be continued. So, there are many advantages of operating synchronous generators in parallel. One of the advantage is that they can be used for supplying a large amount of load. Then in case some generator fails, so it does not stop the supply immediately. So, it can ensure a reliable power operation. Similarly, if this maintenance has to be done in due course of time. So, the maintenance in case there is one generator connected only. So, during maintenance you need to go for the load shedding, but in case if there are number of generators connected in parallel, so supply can be carried out from the other generators which are there. So, maintenance scheduling can also be done very easily. And another is that single generators, these are not operating at a full load, it may be inefficient. So, we need to use them in parallel, so that they can be used to their full capacity and full condition, and maximum utilization can be done. The generators they are to be connected in parallel, but it is not so easy to connect them in parallel. There are certain conditions which we need to follow, because if we connect them arbitrarily, it can result into damage of your generators. If you see here in this particular figure, there will be a generator which is already connected to a particular load, and if this generator number 2, it is to be connected to this particular load. So, here what we do, that if the voltages are not exactly same in the line, like voltage of A and A dash, B and B dash, and C and C dash, they are not close, a very large amount of current will flow, and this current will again pass through the windings, and that can damage the windings. So, that can be very dangerous for the machine. So, that is what we need to be very sure about, that when we connect them in parallel, that the voltage should be same. Similarly, the RMS value of the line voltage, it must be equal. Two generators must have same phase sequence. Phase sequence is also very important. I hope you have an idea about the phase sequence, because we know that this is the three phase supply. If you see this particular diagram, this is particular A, B and C, and if we connect them in parallel, the voltage that is here, it right at particular instant in phase A, and it is having maximum value. And if we connect a alternator with different phase sequence, where A is not having maximum value, rather B is having maximum value at that time when there was maximum value of A in particular generator to which it is to be connected. So, that may result into the voltage difference, but in case the same phase sequence is there, so both will have the same voltage. So, there will not be any circulating current, because voltage will be equal in both the generators which are going to be connected in parallel. So, that is why two generators must have the same phase sequence. The phase angles of the two that must also be equal, that is also important. So, it also is dependent upon the frequency, so that can be shifted by that. So, frequency of this incoming generator, it must be slightly higher than the frequency of the machine which is already running. So, these are some conditions that must be followed to before we connect two synchronous generators in parallel. See, in this case phase sequence, as I told you already, that if they are out of phase, so they will result into that huge current, because there is a voltage difference in in phase A and maybe in the different phases. If the frequency of the generators are different, a large transients may occur. Transients, again, that can result into a huge amount of current, and that will affect the operation of the machines. The frequency of the two must be very close to each other, but not exactly equal, because I told you that phase angles, another condition that was there, that must be equal. So, it is going to be affected by this. So, if it is incoming generator, it the phase angles, it will change with respect to this running system. So, once we are going to connect, it should slightly be higher than this. If the angles between the voltages is observed, it is felt, if the angles they are equal, frequencies they are equal, the voltage are equal, then they can be connected in parallel. So, then we can operate that switch, this S1 switch, and then it will work smoothly. What is the procedure? The general procedure that is adopted to connect in this parallel. This is, first of all, we have this the different dark lamp methods, or there is another way of finding out the phase sequence by connecting induction motor. So, in this case, what we do, we adjust the field winding current and of the incoming generator and makes the terminal voltage, because the voltage that is generated, it depends upon the field current. So, the field current is adjusted in such a way, so that the voltage of the incoming generator becomes equal to the voltage of the generator which is already there in the system. Then we compare the phase sequence. And how to compare the phase sequence? So, in the phase sequence is compared either using this lamp method. It is, again, if the they are getting bright and dark together, so the phase sequence is same. This is how we can observe, we can see this in the circuit. Or the second way is that we simply connect an induction motor to this supply of the generator and see the rotation of the induction motor. If they rotate in the same direction, so it means the phase sequence is same. If it is different, so there the phase sequence has to be changed. So, how it is done? It can be very easily done through this reversal of the two current, because if you have a sequence, so that can be changed by changing the two terminals of the three phase supply. The frequency of the incoming generators, it is adjusted to be slightly higher than the system frequency. So, it is, again, because in generator what we do, the frequency it will changed with the help of the speed. So, speed you can slightly vary and adjust the frequency and keep it slightly higher than the frequency of the generator which is already there on the system. And once these conditions are met, like voltage is equal, then frequency is equal, phase sequence is equal, then you can connect that switch G2. So, the simplest way to determine the moment when this is by observing the three lights of the bulb. If you use the dark lamp method or bright lamp method, so once the light goes out, you simply pull up that switch and that will get connected. Another way is to connect this through synchroscope, that can also be used, which gives the phase difference, and as a result of that we can check the phase sequence, and that will help in connecting the machines in parallel. So, thank you.